So today's lesson we're going to learn about is finding quadratic regression models given a data set. So our objectives today is to find and interpret quadratic regression models for any given data set. So remember in chapter 2 we dealt with finding linear regression models. So if we had a set of data, we actually asked you to use your calculator to find the linear regression. Here we're going to do the same thing. In fact, the steps are the same. So remember we use the stat button on our calculator. So the first step is to press stat, and then we want to press enter on edit. This gets us to our lists page. This is where we type in our data. So the next step is to enter in your data set for L1, L2. So it could be in table form or it could be a set of values, but we're going to enter in our data set. Once we have our data set entered, we're going to press second mode. Now second mode actually accesses the quit option, which gets you back to the main screen. Once we've done that, we're going to press stat. And now we're going to go over to the calc page because this is where we can do our regression models. To do that, we press right. We go down to number 5. If you notice, that says quad regression. Press enter. We'll get to this page. Once you've gotten to this page, we need to press enter, enter, enter until we get to the calculate, which gives us our equation. So notice how our equation is in standard form of a quadratic. So it's ax squared plus bx plus c. They give you the coefficients of a, b, and c. In fact, a is 2.75, b is negative 4.85, and c is 4.25. Our job is to replace those variables with the coefficients that are given. So our equation would be this: y equals 2.75x squared minus 4.85x plus 4.25 if we sub the a, b, and c in. So let's take a look. Here it says the concentration in milligrams per liter of medication in a patient's blood as time passes is given to the data set below. So if you notice, our left column represents time and our right column represents concentration. The question is when did the concentration reach 0 milligrams per liter? So we're actually solving for when it comes back to 0 again in the second column. Well, let's follow those steps again. So on our calculator, remember we press stat. We press enter on edit. Now, one thing is if you might have some data set values in there, one option to delete those is to simply just press delete until they're all gone. The other option to clear a list is to scroll up so that the list is highlighted. So notice how my L2 is highlighted. If you press clear, not delete, but clear, and then down, it will wipe the whole list for you. So those are some quick, easy ways on how to delete your lists. But let's enter our data in. So L1 is going to represent time here, our first column of data. So we have 0, 0.5, 1, 1.5, 2, all the way to 2.5 hours. L2 is going to represent our concentration, which is 0, 78.1, and notice how it increases again to 99.8, and then you notice it starts to decrease, which should give you some idea of what this quadratic looks like. We type in 50.1 and then our last data set of 15.6. So remember the next step, once we have our data set in, we go to second mode to quit back to the main page. We press stat, we scroll right to calc, and we want to get our option of number 5, which is quadratic regression. We press enter, and we want to press enter until we have our equation. So here's our equation with our a, b, and c. So if we enter our a, b, and c in for coefficients, we have our equation of, well, to 2 decimal places would be negative 56.21x squared plus 139.31x plus 9.35. Now remember, the question was when did the concentration reach 0 milligrams per liter? So we're actually solving for our outputs, our second column data. Well, that's our y variable here. So really you're setting this equation equal to 0, which should be familiar. Well, I know one way I can solve this problem is by graphing. I know it's not factorable. We could use the quadratic formula, but it'd be easier for us to just graph this. So on our calculator, if we go into our y equals, and we actually type this equation in, so negative 56.21 x squared plus 139.31x and plus 9.35. If we press graph, okay, you'll notice we'll see it go through the origin, which is one data set at 0, 0, but then it gets back to 0, right, looks like shortly after 2 hours here. Okay, so remember to find that, we press second trace, and we want to use our 0 option. We're going to get our cursor as close as we can to that point, which it looks like right there. Left once, enter. Twice right, enter. And remember, we want to make sure those arrows are in the region at which the 0 is located. If we press enter one more time, it'll give us our answer of 2.54. So if we interpret this, what does that mean? Well, it means at about 2.54 hours, our concentration is out of the bloodstream. Let's take a look at one more problem. It says, suppose you're standing in the observation deck at the top of the tower. You drop a penny from there and watch it fall to the ground. So actually this tower we're talking about is the CN Tower in Toronto. It is 1,821 feet tall. The table below shows the penny's distance from the ground at various periods of time. The question is, where is the penny located after falling for a total of 10.5 seconds? Now we could probably get a good estimation here, because at 10 seconds it's 221 feet above the ground. So we could get a rough estimation. You know it's going to be less than 200 feet, but let's find out. So on our calculator, remember, we press stat, go to edit. Let's enter in our data. This time L1 is going to represent time. So 0, 2, 4, 6, 8, and 10. And our L2 is going to represent distance. So it looks like it starts off by dropping at 1,821 feet. And it continues to fall towards the ground, decreasing the height. Now you can use several variables when we actually described this. Last time we did y and x. Maybe we could use t and d to represent our time and distance, our independent and dependent variables here. So remember, once we have our data set in, we press second mode. We press stat, go to calc, and we want to go down to number 5, which is quadratic regression. Press enter until we get our answer. And here we go. We actually get an answer of a equals negative 16. We don't get a coefficient for b. And we get our coefficient of c, which is 1,821. So, in our equation, if we put it all together, if we use d as our distance and t standing for time, we get d equals negative 16t squared plus 1,821, which should look familiar because remember in vertical motion, we saw this negative 16 take an effect. In fact, that was gravity, acceleration due to gravity. And remember, our constant term represented our initial height, which makes sense here. We're dropping it from 1,821 feet up in the air. And there's no initial velocity. That would be our v value in this equation. Now, our question is, where's the penny located when it's at 10.5 seconds? So, if we sub 10.5 in for t, I'm guessing we'll get our answer. And when we do that on our calculator, we should get an answer about 57 feet. So, remember the steps, quadratic regression. Tomorrow we'll get some practice. Okay? Enjoy your night.